This video is for the homework for day 2 of solving exponential functions with common bases. There are 4 problems. Number 1 says 4 to the negative 2x times 4 to the x equals 64. Now, you need a couple of exponent rules here, but the first thing that I would do is make sure that you have a common base for every single piece of the equation. Now, it looks like my common base is going to be 4, but if you need to, double check with your know your powers here. If I look at 4, the row with 4, I do have 64. I have 4 to the third is 64, so I'm going to use that value to rewrite 64. So the left side stays the same. 4 to the negative 2x times 4 to the x. Now instead of 64, I'm going to rewrite that as 4 to the third. Now I have common bases across. Now one rule that we know about exponents that we're going to have to employ here is that if I have the same base, so we're looking at the left-hand side of the equation, they both have the same base, what you're going to do is you add the exponents together. So what that looks like, I'll write it out in an extra step, is we're going to have 4 to the negative 2x plus x power. You don't multiply them. This isn't power to a power. We just add those exponents, and they equal 4 to the third. Now, just like we've been doing, because the bases are the same on both sides, now I can set the exponents equal to each other. So I have negative 2x plus x equals 3. Well, if I combine like terms on the left side, I have negative 1x equals 3, and then divide by negative 1. So x here is going to equal negative 3. Now remember, we've talked about how easy it is to check your work. You can just use your calculator, type into your calculator 4 to the negative 2 times negative 3 power times 4 to the negative third. And when you type that into your calculator, see if you get 64. All right, next one. Number 2, I have 27 times 81 to the x equals 1 over 9 to the x minus 1 power. Okay, so here's what we're going to do. Let's rewrite 27, 81, and 9 with common bases. Now again, look at your common base chart. Where do I see 9, 27, 81? Well, they're all in the row here with the 3's. 3 squared, 3 cubed, 3 to the 4th. So let's rewrite each and every one of those bases. 27, we looked at our chart and see that that's 3 to the third. There's that first one's rewritten. All right, 81 is 3 to the 4th. So I'm going to rewrite this as 3 to the 4th, and I'm going to put 3 to the 4th in parentheses. And I have to keep the same exponent of x. That x doesn't disappear yet. Equals, now 9 is in the denominator of a fraction. 9 is 3 squared. Since it's in the denominator, that means it has a negative exponent, so it's 3 to the negative second, and I keep the same exponent here. Now I am going to have to use a couple different exponent rules to simplify this, but the first one I'm going to use is power to a power. I'm going to multiply the exponents that I just found from changing the base times the original. So let's write this one out again. So I have 3 cubed times, this is now 3 to the 4x power, 4 times x, equals 3 to the, I multiply the negative 2 by the x and by the negative 1. So it's the negative 2x plus 2 power. Now, just like number 1, on the left-hand side, I can simplify, because these have the same base, I can simplify by adding the exponents together. So I will have 3 to the 3 plus 4x power equals 3 to the negative 2x plus 2 power. All right, now, because those have the same base, now I can set the exponents equal to each other. And I have x on both sides, so what I'm going to do first is I'm going to add the 2x, which will give me 3 plus 6x equals 2. I subtract 3 to get 6x equals negative 1, and divide by 6. So here my x is negative 1/6. And just like the the previous problem, I can check my answer. Put negative 1/6 in for x on the left and on the right and see if you get the same value. Okay. Number 3. 243 to the k plus 2 power times 9 to the 2k minus 1 equals 9. Okay, let's see where I have 9s and 243s together. Looks like they're both powers of 3, right? I have 9 is 3 squared, 243 is 3 to the 5th. So let's rewrite. I'm going to rewrite 243 as 3 to the 5th. Now that exponent of k plus 2 does not change, it stays the same. 9 is 3 squared, so I'm going to rewrite the 9 as 3 squared, and the exponent of 2k minus 1 stays the same. And I have to rewrite the 9 on the right side to be 3 squared. Now I have bases of 3 for everything, so I'm going to use my exponent rule to simplify. The first one I'm going to use is power to a power. Okay? So what I have is the base of 3. Now that 5 multiplies by the k and the 2, so the power is 5k plus 10. On the next one, the 2 multiplies by the 2k and the negative 1, so I'll have 3 to the 4k minus 2 power, and 3 squared stays the same on the right. All right, now both other problems, 1 and 2, have had the same thing. I have the same base on the left, so I have to add their exponents. So be careful here. The base of 3 is the same. Now I have 5k plus 4k, which is 9k. 10 plus a negative 2 is 8. That's the exponent, equals 3 squared. All right, now that they have the same base, I can set the exponents equal to each other and solve. All right, so now I just have to solve for k. So I'll subtract the 8 and get 9k equals negative 6 and divide by 9. And then that simplifies. Negative 6 over 9 is negative 2/3. All right, one more on the practice. I have 1/6 to the 3m times 36 to the negative 3m over 1 to 36. All right, if you need to find a common base, look at your powers chart here. 6 and 36 are going to be powers of 6, so that's going to be our common base. So let's see, if I have a fraction, remember that means your exponent when you rewrite it is going to have a negative exponent. So this 1/6 will be 6 to the negative 1 power. The exponent of 3m stays the same. 36 gets rewritten as 6 squared, and its exponent of negative 3m stays the same. And then 1 over 36 gets rewritten as 6 to the negative 2nd. Now I have common bases. I'm going to use all my exponent rules. So the first one here that I'm going to use is power to a power. And I'll rewrite this as 6 to the negative 3m times 6 to the negative 6m. Right, so now I have no parentheses anymore, and I can use my next exponent rule, which will be to add those together. So I have 6. Now negative 3 plus the negative 6 is negative 9m, and that's equal to 6 to the negative 2. Now because I have the same base, I can set the exponents equal to each other, and negative 2 divided by negative 9 is 2 ninths. Right? And there's your practice video. Let your teacher know if you have any other questions.